Good afternoon, Professor. This is my MMIC third assignment, which I'm going to submit today. And the assignment is about IPD, and I'm going to explain what I have studied and what I have understand with this chapters and through PPT. So in in this the second topic was for massive device technology. Passive device technology. Now, what is passive device? It's refer to passive is like you can usually refer to resistor, inductor, capacitor. However, it could be filter, divider, coupler, transformer, burner, duplexer, resonator, and other non-switching analog device. IPD has advantages for this, which is very low temperature coefficient of resistance, excellent long-term stability, low stress, extremely tight tolerance, high uniformity, small critical dimension, a great process flexibility, highly reproducible value from substrate to substrate and from batch to batch, easy to service, equipment with long times, and relatively excellent fields. In this MCM substrate comes in three forms: MCML, MCMC, and MCMD. L denotes laminated and C chimeric and D deposited. Now, what is MCML? Is a substrate is an organic eliminated multi-layer to similar standard printed wiring board, and C in C case uses is thick film and co-fired multi-layer chimeric technology such as LTCC. And in D case, modules are created using thin film structures on semiconductor or chimeric base layer with deposit metal conductor and dielectric. And this is the comparison table for method and various substrate material has been used in case of MCCL and C and case of D. And in L case, type has been used organic. In C case, type has been used chimeric. In D case, semiconductor inorganic. In MCML case, technology thick film which is greater than 125 unit meter, and thick film which is greater than 50 meter. And in MCMC case, chimeric type, uh, thick film and process is screening printing. And MCMD case, thin film which is less than 20 meter semiconductor process. And other in MCML case, they are using dry film PR and liquid PR process. Now this is comparison of passive integration technology. In this, there are different types of passive: chimeric, aluminum, electrolytical capacitor, chip type capacitor, integrated chimeric capacitor. In this, passive device can be classified by type of pin or type of surface. Mount it uses such as discrete array or integrated. Passive processing different electrical performance and characteristic have different structure, material, and tolerance. In this, the performance sorry consists of two different kinds of configuration: discrete and integrated passive device. In discrete passive device, surface mount device, SMD resistor, SMD inductors, and multi-layer CMRIC capacitor. In integrated passive device such as HTCC, LTCC, thin and thick film passive devices has been used. In SMD passive device, uh, as you can see in this picture also, various SMD passive device used as a surface and mount technology. uh, in this you benefit of surface mounting PCF are therefore not available, and use an SMD passive device have no different from through hole component as far as their electrical functions are concerned. Not all components are available in surface mount configuration for electronic at this time, and the use of through hole component such as pin grid array for high end processor and large connector will keep the industry in mixed assembly mode for foreseeable futures. In this slide topic is about multi-layer CMRIC passive device. As you can see in figure 2.3, it's illustrate about multi-layer CMRIC scenarios. There are many things: wire bonded dies and explanter and multi-layer capacitor, multi-layer couplers, shoulder balls and passive component, and many more things is there. And there is a high level of this is a very high level of system integration lead to the advance of IC technology research, and which combines multiple application specific IC, AISI, RFICs with high density interconnected and miniaturization. Passive component is desirable for commercial while implantation, and there is this multi-layered CMRIC passive technology has found application in military, space, automotive, and in medical electronics industry. Due to because it had advantage of high performance and excellent reliability. And this photograph is about it's a two type of multi-layer CMRIC passive device. The first A figure is about multi-layer CMRIC capacitor, and the B figure is about multi-layer CMRIC inductors. So first one is capacitor and the other one is inductor. Now in this LTCC passive device, the main LTCC fabrication process flow in this LTCC had widely used microelectronic industry and multi-layer substrate and hybrid structure fabrication. It is possible to design sophisticated high frequency system operating frequency between 800 megahertz to about 100 megahertz gigahertz. And in this technology, advantage of other packaging technology such as HTC C multi-layer structures of LTCC contain of several mechanical bonded dielectric tapes, and therefore the active component can be integrated with this LTCC substrate using this wire bond and flip chip or surface mounting techniques. And next slide is about embedded passive device. In this The first figure is about passive component confined to a board surface. Top is for at the top or embedded in the substrate bottom. And The next figure is the photograph of embedded passive device. In this topic, what the main thing I have understood that it's a significant reduction with overall system mass, volume, and footprint by eliminating the surface mount and increase circuitry density through the space. And it also improve electrical performance and elimination of lead to reduction, an increase in design flexibility, elimination of lead based interconnected, and potential reduction in overall cost. And the one main advantage of embedded passive device is significant reduction in overall system mass and surface footprint. Surface mount required in inordinate number of lead on the surface in order to connect to the substrate, whereas embedded passive device need only functionality required. And in embedded passive device, I have also gone to one point, that is substrate of mechanical support and protection, so that additional packaging is not required. Okay, this thin film passive device. In this, as you can see in this figure 2.10, that is about it's a component based on thin film. First it is of single layer coil, then double layer coil, then parallel plate capacitor, and then a resistor with connection. In this, uh, uses two measure approach of high performance LTCC and TF-IPD that can be realized with passive element. And the as you can see in this photograph also, there is a band pass filter 2, and low pass filter, band pass filter 1. And this and I have also gone through this comparison table of different passive technology. In this, it has certain advantages and disadvantages with the particular specific passive device. In discrete, it is easy. Advantage is easy to SMT, and disadvantage that is large in size. And in LTCC, the high integration, high frequency coverage, it has a disadvantage. And it in disadvantages, low yield, low RLC value. And in thin film on glass, proof proven technology more reliable than LTC. And disadvantage that it can easily broken, low power handle. And in thin film on HRS, reliable process, high yield, low price, good thermal dissipation. And in disadvantage, low frequency coverage. Thin film on gas is high yield, runtime, good insertion loss, good power handling. And the disadvantage is that it is high cost. Thin film on AI, advantage that is low in cost, and disadvantage low density cap. mm, this is about foundry environment. In this, as you can see, this is the stages of fabrication for typical gas, GAAS IPD, incorporating TFR, and spiral indicator inductor, sorry. And MLM, capacitor, and air bridges. In this, it includes first of all, it includes TFR, spiral indicator, MMI capacitor, average interconnector through wafer. And the first metal layer is applied using a electroplating method, but thereafter options such as e-beam evaporation. The main IPD fraction machine are divided into four general categories: metal dielectric layer deposition equipment, metal dielectric layer removal equipment, photoresistant uh, patterning equipment, measurement equipment, uh, and the pattern machine are composed on the stepper and the track and contact, a langer and 4-point probe, a surface profiler, and SEM and atomic force microscope focused on a beam, and probe station are used for measuring. Okay, this slide is about what the previous process has been done for manufacturing IPD. This figure is about a cross section of previous process, uh, what they were using in the previous process. They were using the GAS based fabrication that enable the integration of discrete passive component on an IC. This method is highly competitive in terms of reliability, cost, and yield. And yes, the fabrication process need for creating high performance IPD, and the process has been modified in order to develop more reliable, more cost, and high yield fabrication process. Feature of fabricated device still categorized and compared to this original process. Thank you for the day. Thank you for this assignment. Sorry.